Next, we are taking a scenario for the next example, that is for the grade allocation. Prepare a flowchart to read the marks of the student and classify them into different grades. Marks to be read, and we have to classify them into different grades. If marks are secured or greater than or equal to 90, then the student is awarded as a grade A. When the marks secured are greater than or equal to 90, then student is awarded as a grade A. If they are greater than or equal to 80 but less than 90, it's greater than 80, less than 90, the grade B is awarded. If they are greater than or equal to 65 but less than 80, the grade C is awarded. Otherwise, we have to award the grade D. So this is a flowchart for this. Okay, start, read marks. Okay, we have to read the marks. Okay, in the variable for parallelogram used, and we check using diamond symbol. Are marks greater than 90? Yes, if it is greater than 90, the grade A is allocated. Then what will happen? Then we have to we will join the line here in this state that okay, then it will join the line. The arrow will mark to the print grade and stop. Then we check. Then there's a situation that okay, are mark greater than 90? No. Then we have to check are mark greater than 80. That means that okay, the mark which is less than 90 and as well as greater than 80. In this case, the grade value is B should get allocated. It no means okay, again it is S means grade B is allocated. No means okay, the mark is not greater than mark is okay, not greater than equal to 80, which is less than 80. In this case, you have to check that our mark greater than 65. That means the mark is less than 80 and greater than 65. In this case, you have to allocate grade equal to C. If it is no, means grade equal to D. So finally, connect all the lines. Okay, all the arrows should be connected. Okay, they end with the print gate symbol. It is a parallelogram. Finally, it reaches the stop symbol. So this is a simple flowchart. Okay, which have a decision making structure. Okay, which follow this decision making structure. We are having using decision box. Okay, as well as this roots of quadratic equation and as well as allocating grade, they follow the decision making structure. Next, we have to see a flowchart example for a looping structure. Program to print the even numbers between 1 to 100. We have to print the even numbers between 1 to 100. Okay, then start, and we have to assign the value. Okay, a variable num equal to 1. We are checking that while num equal to 100 reached, we are checking that okay, initially the num value is 1. Okay, num equal to reached means no. Then we have to divide number modulo 2 equal to 0. All the even numbers, okay, modulo operator used to find the remainder of the given division operation. So for example, if it is equal to 0 means okay, then we have to print the number. It's the even number. For example, 1 modulo 2 means the value will be 1 because the 1 is less than 2 means the same number will be written. Okay, then okay, then it won't come to this place. Okay, then it will go to compute num equal to num plus 1. Num will become 2 now. Okay, we check num equal to 100. No, okay, 100 is not reached. Again, we check if 2 modulo 2 equal to 0, true. Okay, then 2 will get printed. Okay, next equal to one value will get increased for num equal to 3, and we check while num equal to 100 reached no. Okay, then we check 3 modulo 2. Okay, 3 modulo 2 remainder is 1. Okay, then it is false. Okay, to check the number, it's 4. 4 will check okay, number is while num equal to 100 reached no. Okay, only for num value is 4 only. We check 4 modulo 2 equal to 0. Yes, okay, then 4 will get printed up to this. Okay, right from 2, 4, 6, 8, 10 up to all the values up to 100 will get display. All the even numbers between the 1 to 100 will get printed. Finally, the flow will come out and it will stop the process. Okay, so these are all the few examples for the flowcharts. We have to discuss about the advantages and the disadvantages of the flowchart. Advantages: communication. It's a better way of communicating the logic of a system. It's a better way of communicating the logic of a system. Effective analysis. Problem can be analyzed more effectively. Effective analysis means problem can be analyzed more effectively. Proper documentation. It's a good programming documentation needed for various purpose. Flowchart is a good documentation. Efficient coding. Guide or blueprint during the system analysis and the program development phase. Okay, it is lead to very efficient coding. Proper debugging. Flowchart help in debugging. Debugging means removing the error from the program is known as a debugging. Flowchart help in the debugging process. Efficient program maintenance. Maintenance of an operating program become easily with the help of the flowchart. Flowchart having certain limitations. Flowchart having certain limitations. Complex logic. The program logic is quite complicated. In such a case, flowchart becomes complex and clumsy. If it is a very complex logic, this flowchart will also become so complex. This is one limitation. Alteration, modification. The program logic is quite complicated. In such a case, a flowchart become complex and clumsy. Okay. And in this case, the alteration modification is very difficult. Reproduction. since the flowchart symbol cannot be typed, the reproduction of the flowchart base become a problem. Okay, flowchart symbol has to be drawn. It is not typed. Okay, the reproduction is very difficult task. Loss of objective. The essential of what has to be done can be easily lost in the technical details of how it should be done. Okay, the essential of what has to be done can be easily lost in the technical detail of how it should be done. Maybe by drawing a flowchart, we may lose the objective. The purpose of the flowchart may be lost in due course. We can lose it in due course. Then tracing an algorithm to a depicted logic. An algorithm can be easily traced by verifying every procedure one by one to determine and confirm the corresponding result that is obtained. For example, okay, you are giving a value, you are able to find the value of a particular algorithm. So if you give a value read n, here t equal to 1, f equal to 1, and f star, and the value is okay 1, then we check that t greater than n. Okay, the value is okay, t is not greater than n. No, then again t is become t plus 1. Okay, t is become 2 now. We check f equal to f star t, 2 into 1, 2. For example, we are having a value 5, no? Then we check 2 greater than n, no. Then will happen t equal to t plus 1, 3. 3 star, already 2 is there, 3 into 6. Okay, 3 greater than 5, no. Okay, again it will go 4. 4 into 5, 20. Then we check 5 greater than n, sorry, then 5 greater than 5, no. Okay, then we check 5 into 4 equal to, sorry, 20 into 5 equal to 100. Okay, it will go, and if you trace like this, you are able to find the logic of the program. Especially this logic is actually given for the factorial, to find the factorial of the given number. So you have to trace and find by giving a value, that you are able to find the value by tracing the algorithm flowchart to find the logic of a program. Okay, this logic is especially given for factorial of the given number. For example, if it is 5 means you give a value up to, okay, 5 will have a value t equal to 1, f equal to 1. Okay, 1 into 1 equal to 1. Then what happen? 5 then 1 greater than 5, no. Then t value become 2. 2 into 1 equal to 2. Then 2 greater than n, no. Then n is become 3. 3 into 2, 6. Then what will happen? 6. Okay, then 3 into 6. Then 3 greater than 5, no. T plus 4. Okay, then 4 into 6, 24. 4 into 6, 24. Okay, then 4 greater than 5. Sorry, 5 now is 5 greater than 5. No, sir, 4 greater than 5, no. T equal to t plus 1, that means t is become 5 now. 5 into 4 equal to, sorry, 5, salary we are having a value of 24 into 5 equal to 120. Then then if actually 5 greater than 5 equal to, no, then it will 5 greater than 5 is no, then it will come, sorry, actually the value is 4 now. Actually then it will become 5. Okay, 5 then it is becoming this place 5 greater than 5 plus 1 equal to 6. Then after the multiplication it will come to this place. Okay, then actually then 6 greater than 5 is yeah, yes, then it will print the result and come out. Okay, by using this you are able to trace the algorithm. So set of exercises are given here. You have to try the exercise. Algorithm for making a telephone call. Okay, you have to write the algorithm. Algorithm for determining whether a given year is a leap year or not. Algorithm for converting a value in seconds to hour, minutes, and seconds. Algorithm for finding the second largest number among the n natural numbers. Algorithm for calculating and printing the total cost of purchases made and detail of the item purchased. And some exercise in flowchart. Flowchart depicting the algorithm for calculating and printing the total cost of purchase made and detail of the item purchased. Flowchart for printing the area of circle for a given radius. So radius is given, you have to calculate the area of circle. For this you have to draw the flowchart. Flowchart for finding the divisor of a given number and print it. Flowchart for computing the sum of the digits of the given number. Flowchart for calculating the sum of given n odd numbers. Flowchart for computing the sum of squares integer from 1 to 50. These are all some examples. You have to try the example. So that's it for the flowchart. Thanks for watching the